Hello, I hope this video finds you all doing well. This is lecture 5 and it's going to be a very short lecture. It's on ionic compounds, just to give you an introduction to what ionic compounds are, what they're made of, etc. So it's going to be a very short video. In the next video we're going to be getting more into ionic compounds. Basically we're going to be talking about naming of inorganic compounds. So this is just a short introduction video. So let's begin. So we remember from our first lecture that atoms are made up of different subatomic particles, and these different subatomic particles are protons, neutrons, and electrons. The protons and neutrons make up the nucleus, and the electrons orbit outside the nucleus. So it's important to note that in most chemical reactions, the protons and neutrons remain untouched. So in most chemical reactions, the amount of protons and the amount of neutrons remain untouched. It's the electrons that are directly involved with the reaction. So electrons can be directly influenced during a reaction. So this means reaction. So what do I mean by this? Well, electrons can be gained. So atoms can gain electrons during a reaction. Atoms can lose So atoms can lose electrons during a reaction. And electrons can be shared. So when electrons are gained or lost, ions can be formed. So what is an ion? An ion is a charged species. So why do you think when an atom gains or loses electrons that they'll gain a positive or negative charge? Well, if you remember, electrons are negatively charged. The specific charge of an electron is, so one electron is equal to negative 1.6 times 10 to the negative 19th coulombs. So that is the SI unit of charge. So this means charged. So when you lose an electron, your atom gains a positive charge because it just lost a negative charge. And if your atom gains an electron, it gains a negative charge. So a cation is a positively charged, so this means charged, species. And this comes from losing an electron. An anion is the opposite. It is a negatively charged species. And anions are formed by gaining electrons. So the gaining and losing of electrons can produce different types of ions, either a cation or an anion. So an ionic compound is basically the interaction between two charged species. So they are compounds made up of two charged, so this is charged, atoms. And ionic compounds tend to be formed by the gaining or losing of electrons. So they form from electrons being lost by one participating atom and gained by the other. So in an ionic compound, electrons are lost from one species, and then those electrons are then transferred onto another species, forming two charged species, which form an ionic compound. So some examples of ionic compounds are your salts, so sodium chloride, magnesium chloride, etc. So it's important to note that ionic compounds tend to consist of metals and non-metals. So when you see a metal and a non-metal in general chemistry, think of an ionic compound when those two are together. So I want to look more into how, let's show how this works, how the electrons are lost and gained through a figure. So here I have sodium chloride, okay? So all atoms start out neutral. Start out neutral. So all atoms start out neutral in this case. In other words, the number of protons equals the number of electrons. So all atoms expressed on the periodic table are neutral, okay? So all atoms by themselves, I should actually rename this. All atoms by themselves are neutral. So in other words, every atom that you see on the periodic table, when it's not involved in a compound, will be neutral. So how will this work? Well, sodium, as we're going to see when we get more into atomic structure, has one valence electron. And this valence electron wants to be lost. So in other words, sodium wants to get rid of this valence electron, and we'll learn why in in one of the later videos. So the metal wants to get rid of this lone electron here, and chlorine really wants this electron. So what happens? Well, the sodium, when it interacts with the chlorine, gives its electron to the chlorine. So an electron is lost by sodium and gained by chlorine. So what happens during this process? Well, the chlorine gains that electron, and as a result, the sodium gains a positive charge, and the chlorine gains a negative charge. So it's this positive and negative charge that allows an ionic compound to form. So if we were to draw what this looks like, so the sodium would have a positive charge and the chlorine will have a negative charge with its electron. So let's draw that electron. We can sort of symbolize this bond, so to speak, by these three lines. So these three lines indicate an electrostatic interaction. So in other words, it is the interaction between two charged species, and this is also called an ionic bond. So in physics, there's actually a formula that you can use to find out what the force is between these two species here. So the force exerted on the sodium and the force exerted on the chlorine by the sodium. So the force, or the strength of an ionic bond, can be described by Coulomb's law. You don't have to worry about this for chemistry, but it's just a cool thing to note. So this K is a constant, and these two Q's are the different charges. So this would be maybe the positive charge, and this Q would be the negative charge, and the R is the distance between the two. Between the two species. And an interesting thing to note is that as the charges increase and the distance between them decreases, the strength of the bond increases. So let's write that down. As the charge increases and the distance between the two atoms decreases, the ionic bond strengthens. Okay? So that's basically how an ionic bond is formed. We're going to get to learn more about why this happens in a later video when we once again learn more about atomic structure. But for the meantime, all you really need to know is that metals tend to form cations in an ionic compound, and nonmetals form anions in an ionic compound. Okay, so that's all you need to know for right now. So you can actually use the periodic table to predict the charge on a species. So recall that these group 1A atoms here, so we're talking about lithium on down, are referred to as the alkali metals. And these group 1A species can all form +1 charges. And that includes hydrogen as well. Hydrogen can form a +1 charge. So all the alkali metals and hydrogen can form +1 charges. So group 2A metals, or the alkali earth metals, can form +2 charges. And this includes Mg, calcium, strontium, barium, etc. So the other ones that you should know are the chalcogens, and these include oxygen, sulfur, selenium, etc. And these can form -2 charges. And then the last ones are the halides, so group 7, and they form -1 charges. So as we get more into naming and more into using these different atoms to make compounds, the less you'll need to memorize these. And the more we get into atomic structure, the more you'll understand why these charges are what they are. So once we get into atomic structure, we'll have a better idea of why we see these charges on these particular groups. So the last thing that I would like to note is that transition metals, the reason why I don't have transition metals on here is because transition metals can actually form multiple charges. So a great example is iron. Iron can form two separate charges, and that is iron 2 plus and iron 3 plus. So the transition metals can actually form many different types of ions. Okay, so that is it for this video. It was a very short one. Thank you for watching, and if you have any questions, please ask below. In the next video, I'm going to be getting into the naming of inorganic compounds. So we're going to talk about how to name inorganic compounds and ionic compounds and all that fun stuff. And we're going to get into the types of anions and cations that you should know for your exams. So with that, thank you for watching and see you next time.